Hey guys, so here is part 3 of the 5.4 day 2 notes. We are once again solving polynomial equations by factoring. So example 5, we have x to the 4th minus 100 equals 0. So once again, don't forget, we need to make sure our equation set equal to 0. That's good. Now let's determine how many solutions we're going to get. This is in standard form, and the largest or highest exponent we have is 4. So that means we're going to have 4 solutions here. Now notice here that we have a binomial, we are subtracting, and notice the a and c values are both perfect squares. This is what we called last time when we factored a difference of squares in disguise. Okay. So how we're going to do this is, once again, we do 2 sets of parentheses. And instead of just having x and x, we do have to have x squared, because remember, we multiply that gives us x to the 4th. Now we take the square root of 100, and that gives us 10. And then one factor is going to be a minus, one's going to be a plus. Now let's see if we can factor a little bit more. Let's look at our x squared minus 10. Well, notice we have a binomial, we're subtracting, but is 10 a perfect square? No, so we can't really factor this anymore. But what about the other factor? Well, once again, 10 is not a perfect square, and we have a plus. So now what we're going to do is set each factor equal to 0 and solve. So the first one, I add 10, and then don't forget to get rid of that x squared. You take the square root. As I said, 10 is not a perfect square, and really there's no perfect square other than one that goes into it. So we leave the 10 underneath that square root, and then whenever we do take the square root, remember there's 2 solutions, the positive and negative. So we have plus and minus square root of 10. Okay, let's try the other one. The other one, I subtract 10 from both sides. Once again, I take the square root. We already know we can't simplify the 10, but no, we have a negative. That represents square root of negative 1. So anytime we do the square root of negative 1, remember that means we're going to have I as our answer, or an imaginary solution. So I have plus minus I square root of 10. Now let's make sure we have 4 solutions. So we know that plus minus always represents 2. So we have the positive square root of 10 and negative square root of 10. That's already 2 solutions. And then the positive I square root of 10 and negative I square root of 10. That's another 2. That means we do have a total of 4 solutions, and so we did this correctly. Okay, let's go ahead and do our last problem. We have x to the 5th minus 5x cubed plus 6x equals 0. First, this is already set equal to 0, so we're good to go. Now we want to see how many solutions. This is in standard form. Notice that our largest or highest exponent is 5. That means there is going to be 5 solutions. Okay, now let's see if these 3 terms have anything in common we can take out. Notice that they have an x. So I'm going to go ahead and take an x out. And when I do that, I'm left with x to the 4th minus 5x squared plus 6. Now remember, we did some factoring about this. This is similar to we factored a quadratic. Okay. So in doing so, I'm going to bring down my x. And the reason I need to bring down my x is because it is a variable, and it is a factor, meaning I will have to set it equal to 0. Then I'm going to do my 2 sets of parentheses. Okay. I'm going to figure out all numbers that multiply to 6, which is 2 and 3, 1 and 6. Now, instead of having just x and x, remember we do have to have x squared, because that's how we get x to the 4th. Now we need to look, okay, which one's going to give us a multiply to that positive 6, but add up to the negative 5. Now, some of you might say 1 and 6, but if we did that, that means our 6 would have to be negative and the 1 would have to be positive. And when we multiply that, that would not give us a positive 6. So that means we have to have a -2 and a -3 Because if we multiply -2 times -3, that does give us the +6. So there is actually only one solution for factoring. So let me go ahead, I'm going to show that one way, just in case you guys are a little bit confused of what I was saying. So I was saying if we had -6 and then x squared plus 1, okay? Because -6 plus 1 just gives us -5. But if we multiply this -6 and 1, that gives us -6, not positive. So that's why this doesn't work, okay? Okay, now let's look at our factors. Now, x on the outside is just a linear, and it's a monomial. Linear is a monomial, so you can't factor anymore. But let's look at an x squared minus 2. It is a binomial. We are subtracting, but notice that 2 is not a perfect square. So this is not a difference of squares, and we can't factor this anymore. Okay, what about our next factor? Once again, we have a binomial, we're subtracting, but 3 is not a perfect square as well. So this is not a difference of squares, so we can't factor anymore. So our last step that we need to do is set each of these factors equal to 0 and solve. So I set x equal to 0, my x squared minus 2 equal to 0, and my x squared minus 3 equal to 0. Well, x equals 0 is already solved for, so no need to do anything else. The other one I'm going to add 2 to both sides and then take the square root. I get x equals plus minus, because remember when we take the square root, we get 2 solutions, square root of 2. I do basically the same thing on the next one. I add 3 to the other side, take the square root. Know that 2 and 3, they're not perfect squares, and there's no perfect square that goes into them, so we can't simplify, meaning I just left with x plus minus square root of 3. Now let's count to see that we have 5 solutions. Well, x equals 0, that is a solution, so that's 1. And then remember the plus minus always represents 2. So we have positive square root of 2, negative square root of 2, so that's 1, 2, 3. And then same thing here, 4, 5 for that positive negative. So we do get 5 solutions, and we did do this correctly. Okay, make sure if you have any questions, you contact me, and make sure you work on the homework assignment. I'll see you guys later.